Again, welcome to Data Science course. In these lectures, we're going to discuss about data visualization. Again, in our previous lectures, we discussed about data visualization, mostly based on a hands-on using the R package, the ggplot2 package, the R package for data visualization. In these lectures, we're going to focus mostly on theoretical aspect of it. So we're going to discuss in general the theory aspect of data visualization. What is data visualization? Why we need it? Different types of charts based on, again, the type of data we are trying to visualize. So our main objective, again, define and describe data visualization. Again, our previous lectures, we didn't discuss about this. We use the R package, which is the ggplot, to do some hands-on with the data visualization using R. In this lecture also, we're going to compare and construct different types of charts and also the appropriate use of them. Also, we're going to discuss about the best practice when creating charts. So first, we start with the definition. Here we say visualization. That is the visual representation of data with the goal of improving communication. So we can say that again, a chart or even a graph is a visual representation of data. And the main goal of, again, trying to visualize the data is for us to be able to improve on the communication or even to find a pattern in the data set. When we plot a chart, we can see the pattern of the data. So again, visualization is the visual representation of data with the goal of improving communication. We have two types of charts. We have the static chart and also dynamic chart. So a static chart means the chart it doesn't change, stay as it is. Dynamic charts, most of them are web-based charts. Again, based on the data, when the data changes, again, the chart will change automatically. So let's look at the definition. A static chart is a chart that does not automatically update based on the changes to the underlying data set. So which means even if the data set is changed, the chart does not change. So that's why, again, it's called a static chart. But a dynamic chart is a web-based chart. Now, the content of which updates automatically when the underlying data set values changes. So in a dynamic chart, again, when the data changes, again, the chart also will update automatically. But with a static chart, even when the data changes, the chart remains as it is. Also, we have a term API, which is the acronym for Application Program Interface. And this describes the code often a library a program can call use to accomplish a specific task. So to create a chart, for example, if we are using R or Python, we may have an application program interface. Example of a Python programmers can use the prot.li API. Also, for example, in Java programming language, we have the API for going like graphical user interface, etc. So again, API stands for Application Program Interface, and most programming languages have it. So it's more or less like a library file that we can use to accomplish any task. We don't have to write the program, the code for it. It's already given to us. So most programming language comes with a visualization API. Example would be Python and R. R use the ggplot2. And we also have the gplot, which is the old version. They are called APIs, a library file system. So the need for data visualization, here we say that data analysis are normally dealing with more data today than ever before. And that amount of data will continue to double every 2 years for many years to come. And now the main goal of a data visualization, or the need for it, is that when we have a very large data set, it's very difficult for us to find a pattern in the data set. By visualizing this data, we can even gain some knowledge from the data. We can see some trends in the data or some patterns in the data. Maybe we saw that there's a relationship between the amount of money a company spends on advertisement and also the revenue. So the more money they spend, the more marketing and advertisement they did. We can find out over 10 years of business operation that the revenue increases. Now, when we have this data set, it's very difficult to tell. But when we plot this data, we can see the pattern. So here we say with ever-growing amount of data comes many opportunities for discovery. However, as the volume of data increases, so do the challenges of discovery trends and patterns, as well as expressing search findings in a meaningful way. Now, in the simplest sense, data visualization is the visual representation of data with the goal of, again, improving communication. So data analysis have a wide range of communication tools available. Example would be tables, charts, and graphs to display of big numbers to represent data. But we are going to again examine many tools in detail and learn when to use each appropriately. So these are some of the, again, data visualization tools. And I will urge you to, again, Google them or go to their website. Again, we will not go detail this, but we may just discuss. For example, a visualization tool called Domo. It's a very good tool. You go to their website. Also, we have Microsoft Power BI, Tableau is very common. Tableau is good. They have it, again, you have to buy it. It's not free, but sometimes they may have a try period, maybe 2 weeks, a month, try. And the most common data visualization tool, and it's free, again, will be the Python and also the R package, Python and R package. So some of the common visualization and visualization chart types, we will go through some of them here. We say we have the time-based comparison chart that represents our variables value changes over time. And also we call this type of chart as a time series chart. For example, a stock price, normally it will change by time. And also, so with the time-based comparison chart, a good chart can be the scatter plot or line chart, also we can use it. And a time-based comparison chart, always the horizontal is always a time period. It can be in hours, years, minutes, seconds, etc. We also have a category-based comparison chart that will represent one or more categories of values. Normally, we can use the bar chart or column chart for a category-based comparison chart. We also have a composition chart that represents how value relates to the whole. Also distribution charts that represent the distribution frequency of values within a data set. Then we also have a correlation chart that represents how two or more variables relate. And dashboard charts that represent key performance indicators, normally on a company dashboard. Then we have the geo chart that charts data against a map. Again, geo means geographical location. So this is our visualization best practice. The first thing they tell us always is begin with your end goal in mind. Know what you want to show before you begin. Keep your audience in mind. If you are presenting to a group of stakeholders with knowledge of your data set, you may only need to present a detailed summary chart. Now, if your audience is new to the data, you may want to use a series of drill down charts that tell the data story. Drill down charts can be have a data set about a company business operations. We may have a chart for one particular department, another chart for different particular department, or different products. Then from there we can again analyze this chart or drill it down. So use the correct chart for the right purpose, and also use color effectively. As we know, visualization, this is more or less like an image, a photo, so color is very important. So users often find colors that differ only slightly within a chart confusing. Users again often find colors that differ only slightly within a chart confusing. Users normally prefer the use of high contrast colors also. So we can also use axis values consistently. Users are used to seeing axis values that begin with 0. So using a non-zero base axis may also lead to confusion. Sometimes, again, when you have a data set and you want to visualize this data set, even using a common chart like scatter plot, again, sometimes the scaling can change the pattern of the data. Instead of starting from 0 to 100 with 10 interval, let me say, okay, I'm starting from 40 to 100 with 5 intervals. This can change the pattern of the data, how the data is represented. So avoid the clutter. Also focus on actionable content. Always a good chart informs, and a great chart is a call to an action. And keep it simple. And that's one of the key words in computer science. Always we keep things as simple as possible. And also build a user trust. Do not misrepresent data. We can easily misrepresent data even by just changing the scaling of the data set. So we have to be careful with. And also avoid practices that may be perceived as distorting data, such as using non-zero base axis or 3D pie charts. Also, we should make sure that your chart axis labels are easy to read. Also use a meaningful chart title that begins to tell a story. We should also sort the data appropriately. If possible, alphabetize category-based data and display dates in order. We should draw the viewer's focus to key points. Now, if your chart's goal is to highlight a key value, use a different color to highlight the value bar or marker within the chart. We should also consider using a graphic artist. And depending on the chart's importance, you may want to leverage the skills of a graphic artist to improve the chart's appearance and also messaging. So again, those are the best practice in charts. But again, this is just a conventional concept, but in general, most of them are, again, a good practice. Now, selecting the correct chart. Again, selecting the correct chart will be based on the type of data you have. Even just by having a data with more than 2 variables, I may not use a scatter plot or I may not use a line chart. I have a data that has some category of cells from different states. I may not use a line chart. Maybe I may use a bar chart or column chart. So very important, based on the type of data, we may have a chart that is good for that very specific data. So yeah, we say many analysis will criticize the use of pie chart because it can be difficult for viewers to determine the area of which each slice. Those same analysis also will often state that a 3D pie chart distort the data representation. So such criticism are more than opinions. Researchers have examined how factors such as the use of different chart types and the use of colors and fonts within a chart impact the viewer's accurate understanding of the chart presentation. So the research has also showed that statements such as pie chart criticism often have a factual basis. So common chart types, again, we have even a common Excel program, Microsoft Office Excel. Most of all these charts are there. So for example, we have the pie chart, scatter plot, and this can be a column chart or bar chart, and area chart, etc. So we'll go through each one. First, using the Google chart. Advantage of using a Google chart, again, is free. So it's free to use. Also, it supports web and also mobile solution, and it's easy to integrate. Google Chat now is very common, and also, again, it's a free. Now, creating a real-time chart. Here we say the symbol used to represent data point on the chart. The marker might be a circle, an X, or some other meaningful shape. So we can have a client web base, we have a server with the internet connection. Again, I can get data and I can visualize the data, create a chart, a real-time chart online. A time-based comparison chart, as we said earlier, the common word also used is time series charts. So a time-based comparison chart is a chart that shows how one or more set of values change over time. The common example included the line charts and also the area charts. Most of the time, the time-based comparison chart, the x-axis, the horizontal axis, is always a time. The most common is the line chart or multi-line chart, also area chart. So this is an example of a line chart. We can see we have our time here is based on the days. So we have Monday, Tuesday, Wednesday, Thursday, Friday, and we can see how the sales goes. So sales start to increase from Monday to Thursday, then decrease on Thursday to Friday. Creating an area chart. A chart similar to a line chart. Area chart is always similar to line chart. And the reason why we can see at the top is more or less like a line chart. The only thing with the area chart is that below it's always painted because it's the whole area chart. That's why it's called area chart also. So this chart can represent how values change over time, same as a line chart. So we can see how the values are changing based on the X values. But the area under the data line is filled with a solid color. With the line chart, we don't fill the below the line, we don't fill it with a solid color. So that's why we say, again, the area chart is similar to line chart, the same function. We also have category-based comparison charts. There's so many of them. Example would be the bar chart. We can have, a company can have branches of 20 different states in US, branches in 20 states. We want to create a chart for sales for each branch. So we may have 20 categories of each state. And there's no way we can use a line chart for that. So a very good chart would be either the bar chart or column chart. Also radar chart, combo chart, difference chart, waterfall chart. These are all again category-based comparison charts. And it's normally a chart that represents how two or more categories of values compare. Example include a bar chart and column chart. So a bar chart is a chart that represents the data using horizontal bars. So you can see that our horizontal bars, 4 bars here. And sometimes it can be vertical, sometimes it can be horizontal. So here's across. Actually, these two graphs are the same values. We are using the same value here. So we have quarter 1, quarter 2, quarter 3, quarter 4 cells, and we have their sales values. Profit. Each profit is 1 bar. So you can see here we have negative 5,000 in quarter 3, which means we lose. So it's below 0. So radar chart again is a chart that represents multiple variables across 2 or more axes, the origin of which is center of the chart. So the origin will be the center of the chart. So here we have Java SQL, object-oriented programming, testing, and team fit. And we have the value associated with the A, B, and C. The combo chart, again, the keyword is combo, means two. And here we can see that it's similar. We have a column chart with a line chart joined together. So it's a combo chart. Here we see a chart that represents data using vertical bars, the length of which are proportional to the underlying data value. So a combo chart that can combine a bar chart with a line chart, and this often used. We also have the diff chart, a chart that compares two data sets by representing the difference between them. We also have the waterfall chart. A waterfall chart is a chart that represents the sequential impact of applying the positive, which is increments, and negative, which is the decrement value to the starting value. A composition chart is a composition chart concept is almost the same as combo charts. It's joining 2 or more charts. So here we see represent 1 or more values related to the larger O. They include pie charts and symbols charts. So composition chart can be a pie chart, donut chart, symbols, stack bar or column chart, stack area chart, tree map, funnel, and pyramid. So a pie chart, again, is a chart that represents 100% of the O as a circle and the values of the components as proportional slice. So we can see we have a full circle 100%, and each color will be some percentage. So we have 39, 25. 25 is the Friday. And we have 35, which is Tuesday, etc. We also have the 3D pie chart. Again, the difference you see 3 dimensions, X, Y, then the Z. And here we see too many pie chart categories. So here we have a pie chart with about 10, 20 categories. And this is a donut chart. We have 3 categories: machine learning, data mining, visualization, with different rating. We plug in the values. Also, the symbols chart. This is a chart that displays hierarchy related data using a multi-layer circular shape, similar to multiple layers of a pie chart. Then we have the stack bar and column chart. So a stack column chart is a chart for which the primary or aggregate rectangle column bar comprises of 2 or more component rectangles. the length of which is proportional to the component value. A stack bar chart, again, is a bar chart for which the primary or aggregate rectangular bar comprises of two or more component rectangles, and the length of which is proportional to the component value also. We also have the stack area chart. And a stack area chart normally is a chart that displays two or more area charts on the same graph for comparative purposes, or to represent each area's percentage of the whole. We also have the Treemap chart. This is a chart that represents hierarchy related data using rectangular boxes nested within other boxes to represent a parent-child relationship. The area of a box is proportional to its underlying data value. Then the funnel and pyramid chart, a chart that the shape of which resembles a triangle, for which the bottom of the pyramid represents 100% of the whole, and the area of each section represents sections of the line values. We also have a correlation chart. The whole concept is find relationship between two variables. Here we see a chart that represents how two or more variables relate. So example will be the scatter chart and also the bubble chart. The scatter chart is a chart that represents the S and Y. S will be our horizontal axis, Y will be our vertical axis. And we want to find the relationship between the S and Y. And a bubble chart is almost same as correlation chart, but again, the symbol are bubble. Also, we have the gauge chart. This is a chart that appears similar to a die on an automobile dashboard that represents a value. Then we have the candlestick chart, a chart that is used for financial data that represents stocks, open, close, high, and low values, with the color of the box representing whether the stock closed positive or negative. Then distribution chart, again, is a chart that represents the frequency of values within a data set. The common example is the histogram. So histogram chart, again, is a distribution chart. And also box and whisker chart is a distribution chart. So histogram is a chart that represents a data set frequency distribution. Always that will be the vertical, and shows the count, the frequency of occurrence of a value within the defined ranges, called the bins. Then changing histogram bin size. Changing the bin size means the number of categories, the bars. We can change it to any amount we want. So we have uni, bi, and multimodal histograms. And we know when we have a data on a chart, there's three possible skewness. Either skew to the right, which is positive. Normally when we skew to the right, it means the mean value is greater than the median. When it's symmetric, it means the mean value is the same as the median and is the same as the mode also. Then when it's skewed to the left, it means the median value is greater than the mean. That's the data set that it's representing. We also have the box and whiskey chart. The box and whiskey chart normally find the location of our data set most values. So for example, we have Q1, Q2, and Q3. Q1 will give us 75%. Q1 will give us 25% of the whole location. Then Q2 will give us 50%, which is the same as looking for the median. Then Q3 is the 75%, the top 75%. GeoChart have to relate to location. So a chart that represents how values from one location compared to the values in different locations. Then we have the tableau, which is very common visualization tool. This are used in many companies, and also they have trial version, which we can try for 2 weeks or a month, and then you have to buy it. Also, a dashboard is very important. Most companies have a dashboard chart, and this will be a chart that represents the key performance indicators that companies use to track initiatives. Example include the gauge chart and also the calendar chart also. So we're going to end the lectures here. And again, I wish everybody the best and see you in the next lecture. Again, these lectures, as we said, we focus on only the theory aspect of visualization. What is a visualization? What is the purpose of visualization? What type of charts, different types of charts and their purpose. Now, selecting a chart will be based on the type of data you have, especially the number of variables, attributes you have in the data set will play important role. Now, if my goal is to find a relationship between two variables, most likely I will not use a pie chart or a column chart. I may rather use the line chart or scatter plot. So again, this lecture we discuss only the theory. We already do some practicals using the R package, ggplot2. So again, thank you.